Welcome to the presentation about increased Scrum team effectiveness using flow metrics. My name is Zoran Vujkov. I'm coming from United Cloud. And this is my lovely assistant, or my colleague, dear Bojan. He is from Agile Corner. We will talk today about these interesting topics, I hope. I must admit, there's lots of audience. I didn't expect that many. So obviously, there is a pressure. So let's start. First of all, raise your hand if you're using Scrum framework to develop your product. OK? Raise your hand if you think you are successful using Scrum. OK. Can I have your emails later on, please? OK? Raise your hand if you are using velocity to define your capacity in the sprint and predict the future delivery. OK? And finally, raise your hand if you're estimating in story points. Oh, my God. OK. I promise my colleague I won't comment anything, so I do apologize. OK, so oops. Here's some of the challenges which we think the Scrum team's facing. This is based on our experience working with Scrum teams for many, many years. There is no particular order or priority in the challenges, but let's mention some of them. So first one is related to the monster stories, as I like to call them, because these monster stories travel from sprint to sprint, and there is no end to them. The challenge there is that with that kind of stories, first of all, teams, they face lots of uncertainty and risk when developing this kind of requirements or product backlog items, if you like. The second, by the end of sprint, you don't have a product increment in accordance to your sprint goal. There is lots of impact on your velocity because there is this discussion about we almost finish all this, 80% we're done. How many points of, I don't know, 13 points we actually use for that and that kind of thing. And it's very difficult to predict what's and plan next sprint because there is always another pressure for another increment and another goal, and you have something left over, so there's lots of turbulence in that. The second challenge, which we usually see, is the concept of multitasking. And I know there is a popular belief that multitasking is killing productivity. We all know that. We hear that many, many times. But still, lots of people doing multitasking. So why people doing multitasking? There is many reasons. The big one is that usually people start working on a certain product backlog item, and they came across some difficulties. And there's this human nature that says, I'm just going to leave that here. I'm going to take another one with less priority. It's easier one. Let's finish that first, and I'll come back to that later. And all of a sudden, you have many things which you work in parallel. And of course, all of a sudden, we get bugs from production or from staging environment. That causes multitasking. And there is a pressure from the product as well, asking for more stuff. And especially if you didn't finish all things from the previous sprint, more pressure. So usually, answer to that pressure is multitasking. And the multitasking, unfortunately, really kills teams' productivity. The next one is scope creep. I heard from many teams there is changes in the sprint. And I don't understand why is that. Because by definition, Scrum framework should work like this. The product owner should come up with a sprint goal, something which he or she wants from team to deliver, because that person is responsible for maximizing the value of development work. And the product owner, together with the rest of the Scrum team, sits on the planning and they discuss why we're doing next sprint. Yeah? What can be done? How can be done? And all this kind of stuff. By the end of sprint planning, usually teams say, okay, we think we can achieve that sprint goal, and here's the list of the product backlog items which we think we need to do. And after that, there is sprint execution. You know? The idea is that you leave your team to complete what they said they will deliver. You know? And all of a sudden, after a few days, maybe even a week, there is changes. There is new stuff coming for many reasons. The simple one is bug. Here's new bug. Important bug which we need to fix. So we have a problem with quality, obviously. You know? The second one is that there is a pressure from the business to change. And the question is why? If we invest so much time in refining, planning things, why are we all of a sudden changing that? Typical reasons can be that, for example, your sprint is far too long and business is not capable to wait for you to deliver stuff. You didn't perform very well your planning, obviously, and business wasn't prepared very well, so you're wasting your time. And all this kind of stuff really shows that there is dysfunction in the way how you develop your product. The next one is team members working alone. So here's coming Scrum saying that we have self-managed, cross-functional, long-living teams. I'm sure you're all aware of that. But usually what happens is that you have individual team members working on individual product backlog items and just purely focusing on that. They don't see anything beyond that. They don't particularly care about what's the rest of the team doing or team overall. And you don't have, you're missing that kind of collective team knowledge, expertise, decision-making. Very important stuff. That's why we have teams. And what typically happens, the people are too much focused on the utilization of your resources, or people, should I say. Huh? Oh, but we can't sit together with some colleague and doing, for example, pair programming, because in that scenario, I'm not doing nothing, and that kind of stuff. Give me my task, and I'll finish my task, and we will meet somewhere when we integrate usually software, and at that point, nothing works, and that kind of stuff. The next one is, it says here, unreliable estimations. Estimations by default are unreliable. So they're not precise, not even accurate. And what's even worse, the estimation as a process is nothing more than guesstimation. So if you have more information and you have better information, you may be able to estimate your effort better. But problem with estimating effort is that we usually estimate just positive scenario. We're thinking that we have all information, we all have people which we need, we don't have any dependency, we don't have any blockage, we don't have any bugs. We're not working on many things in parallel and that kind of stuff. And usually delivery time is far bigger than what we're anticipating. I promise I won't comment about story points. I would just quote Ron Jeffries, who created the story point. He apologized at least 3 times, I'm aware, saying, I'm deeply sorry that I invented that ... Okay? And the last thing is velocity-based planning. Definition of velocity is typically, it says here, amount of relative effort or story points completed per sprint. Very often we talk about average velocity, which is average amount of story points completed per previous sprint. And if you have uncompleted stories, big stories, you have a roller coaster of your velocity. And if you take averages of that, that's almost nothing. And what usually happens is the management is very much focused getting more and more effort, more and more velocity. You continuously have push deliver me more and more velocity, increase your velocity, do whatever, do better estimation, you know? And what team usually do, say, okay, this is maybe 5, I call this now 8. Or even worse, I call it 13. Guess what? We have more points. Great. So focus is on the wrong thing. We're focusing on something which should measure output, but we should be focusing more on outcome, yeah? Of course, we shouldn't forget about output because these two things are tied together. Agile coaches, Scrum masters, and management usually chasing wrong thing. Velocity is not what you should be focusing on. And what's interesting as well, the Scrum from day one had a problem with these two terms, velocity-based planning, I should say, and estimation. And I bet if you open now Scrum Guide, you won't find any reference to either of this. Why? Because there is so much trouble and problem with these two things. And we are in 21st century. We should do things smarter. There is another way how you can do things. Just because you did that 100 times and you fail 100 times doesn't mean you should try 101st time again, you know? Just stop and think about something different. What's even worse, lots of effort, unfortunately, are wasted on your very wasteful, inefficient process. So, doesn't matter how good you are in planning, doesn't matter what planning you do, ignoring your process flow will certainly lead to the problem of your delivery. So first things first, you need to really know what's your team process and what flow they have. So team works flow through certain system. And without understanding that system, using flow metrics, we won't be able to improve and increase team effectiveness and efficiency. When we say effectiveness, what usually means that you deliver great feature, you have great software, great quality of software, and your team is productive. There is no much waste. And estimation, by default, is waste. Because in the end of the day, your client doesn't care if you estimate or not, right? There is shaking hands. So your client actually pays you for your estimation. Is that right? And said, okay, I'm prepared to pay $100. Just do estimation. That's a great thing. I like when you do estimations. So first things first, you need to get a screenshot of your system. The system when your team work and when the team's workflow. That's first thing what you need to do. Because the flow metrics will show you all these functions which you have in that system. And shows you is that system where team works is stable or not. If system is not stable, doesn't matter what you do. First things first, you need to stabilize that system. So you need to remove these functions from that system. These functions can be, for example, you have a bottleneck. You have some resource or some skill set which are bottleneck. Typically, you have problems with like people who do development and people who do testing. And all of a sudden, by the end of the sprint, who is the most problematic person in the team? QA. How is that even possible? I don't understand. How QA can be a problem? Because you do verification. That's one of the disciplines of software engineering. Just because someone is doing that doesn't mean that he's his problem. So you need to see why is that a problem. It's because you sacrifice quality on the beginning, because you have disbalance between people who do development and people who do verification, something like that. So your first job, get a screenshot of your system and try to stabilize that system. Once you stabilize your system, stable system is predictive system. In that system, you can use historical data to get better picture of the future. So first job is stabilize the flow. So flow metrics. Here's one of the most important graphs from today's presentation. It's called cumulative flow diagram. Here you can see All flow metrics in action. So we have few here. One of them is arrival rate. Arrival rate represents number of items entering your system or entering your team's workflow per unit of time. Can be a day, can be a week, can be a sprint. Throughput, on the other hand, is the number of items leaving that system. Usually you will hear from people saying, oh, we deliver that many items per sprint, or per week, or per day. That's usually called throughput. Difference between throughput is velocity. Velocity is usually related to our favorite story points. Here, we're talking about delivering any kind of item. Cycle time is the time between you starting and finishing work on the given item. And WIP is the number of items which team is currently working on. That's a number of items in progress. So when you measure that metrics, you should get information what is this function in your system where teams work. So let's see one example. So this is difference between stable and unstable system. In the first scenario here, we have, by the way, light-brown. That's your in-progress stuff. And this is your done stuff. And this is cumulative done. So if you think about days, and if you take number of items completed, that's cumulative what you deliver. So far, this is cumulative what you have in progress. So we see here the arrival rate is much higher than your throughput rate. As a consequence of that, what we see here is that in this beginning here, work in progress, which defined between arrival and throughput rate is smaller. As we move, getting bigger and bigger and bigger and bigger and bigger. As a consequence of that, cycle time, which is very related to the WIP, this is how long is here. So horizontally difference between these two trends. So as WIP getting bigger, your average cycle time is increasing. And even more, and even more, and even more. So after 3 months, you won't be able to tell what's your average cycle time, because there is no stability in your system. So first things first, you need to stabilize this. So you shouldn't allow that your trend for arriving be bigger than your throughput. Usually what that means that you need to increase your throughput somehow, yeah, magically. But that's not always the case. In the second scenario here, we have a between, let's go back here. You can see the trends are pretty much in a sync or a line, if you like. And you can see here, WIP here, and WIP here, and here, and here, and here, is pretty much the same. Which means that cycle time is exactly almost the same, average cycle time. So what that means, we can in the future give answer to someone asking, okay, if you start working on this item, how long will it take you to deliver that? Here we are. We know how is average cycle time. That's your answer. There is no estimation. There is no story points. Trust me. No story points at all. Okay? So what you need to do, you need to stabilize your system first. You need to take a picture of the system where your teams work. If you have unstable system, just ignore this. It doesn't work. So how these flow metrics can help us with Scrum events, how we make Scrum, or should I say Sprint, more effective. Here's a quote from the Scrum Guide. Scrum Master is accountable for Scrum team effectiveness. How do you know that your team is effective at the moment? Based on what?
Story points.
Story points, well done. Developer story points, QA story points. Do you have anyone like that? Say it again.
Meeting the goals.
Meeting the goals, okay. Yeah, okay.
Functioning software.
Functioning software, yes. Quality, okay. What else?
Flow efficiency.
Flow efficiency. I can, trust me, that's the metric which I can easily game. Easily game. And this is the one which I don't like at all. Oh, yes, that's famous. Happy product manager or happy customers. OK. So we have obviously subjective. I usually get answered like Scrum Master tells me, I know they're good because I work with them all day, every day. I won't comment any of this, except I will say, OK, that's fine. You have subjective view. Yeah? You know when they're doing something. Yeah? But you need to add some objective data to that. Yeah? And quality is certainly one of them, absolutely 100%. But let's see how we can use some of these metrics to help us with all this. And of course, don't forget, we have 3 pillars of every empirical process, and Scrum is definitely one of empirical process. So we need to be very transparent what we're actually measuring and what that actually means. We need to do inspection. When we do expansion, Scrum events is a great place. And we need to adapt. We need to make sure that our system is stable. Again, remove your dysfunctions. Oops. So now we're going to see more examples how we do for each of these events. And I'm going to pass this presentation to my dear friend.
Thank you. Thank you for not using that, my lovely assistant once again, but yeah, thank you. OK, so this is all nice and dandy and looks too good to be true, right? And this might sound like idealistic form of, and naive form of approaching all things. So this is why we wanted to show you our actual examples with the teams we are working with and how we are working with teams using the flow metrics. First thing, as Zoran said, in working with a team, with the Scrum team, we are doing is stabilizing the flow, which means that we really have to pay attention first to stabilize the flow, to stabilize the arrival and departure rate from the system to make the system predictable. We are talking about prediction a lot here. Why is that important? Here, we don't want to use velocity-based planning, so in this, let me go back for a bit, just not to distract you. So, in the first event of Scrum sprint, we have to plan for that sprint. So, how we do that? What we do with our teams? Obviously, first of all, we set goals, defining what we are trying to achieve, and why we want to achieve that. So we give the context to the team. We understand as a team the context, right? And there is that is mostly the easier part. The harder part is how to do that. From 2 perspectives, how to actually do that, technically. And another thing, the dreaded question, how many items can we include into the sprint backlog so we can achieve the sprint goal? How many items, how many items is either guessed by some, I don't know, maybe averaging of sprint velocity historically, or we can use something more, let's say, scientific for this occasion. This is a Monte Carlo simulation. That's the tool using Monte Carlo simulation we are using with our teams. Monte Carlo simulation is a probabilistic forecasting method which uses historical data to forecast the probability, to get you the probability of certain events occurring. So in this particular case, here is the time period we are sampling from. So this is for stable system. This is this time period of throughput, daily throughput data we are sampling from. Because this is stable system, we want to keep it stable, so we can expect that over the months it will continue to be stable. We want to keep it stable so we can make it predictable. And how we do that? We want to set the period of interest for our team, which is a sprint, which for this particular team, it is a 2-week sprint. So we set the period of 2 weeks for which we want to run the simulation. And the simulation is run thousands of times, tens of thousands of times, even hundreds of thousands of times. In this particular case, it's 10,000 times. And it is blazingly fast using modern computers. So you get the result in under a second, right? Milliseconds even. Okay, so we end up with this probability distribution of different possible scenarios of number of items being delivered. How can we read this? First, we have here, I'm using interchangeable my hand and the dot, right? So here, let me do this now. Okay, so here, for this particular team, you can read there is probability of around 85% that they will deliver 23 tasks or more based on past behavior of the system. 23 tasks or more for this team, 85% probability, which is something that we can work with, okay? So this is something nice, yeah? But let's turn the things around and say, okay, there is 85% of probability of delivering as much items, but there is still 15% of risk of not being able to deliver as much items, which means that we are now shifting discussion from guessing probabilities or whatever to risk management domain, right? So we make decision as a team whether or not we are willing to accept that sort of risk for our sprint in order to meet the set goal, right? 15% is a reasonably low risk, and many teams decide to go that most of the time. But there is a context there to be added, right? If you're working on a novel project, new stuff, uncertainty is large, and so on, you might feel more comfortable choosing the smaller or the less risk, right? So you decide to go with something like in ballpark of 2% or 5%, lowering the number of items you're willing to include into the sprint. On the other hand, if you're doing repetitive work, the work that is coming into your system is in your sprint. This upcoming sprint is very well known and done and rehearsed many, many times. You might feel more confident and opting for more risk, saying, okay, we are willing to accept the risk of 30 or even 40%. If you are feeling extremely lucky, then 50% is okay. So, but this gives us the information to actually make an educated decision, to have discussion in an educated decision way on how many items we can include in the sprint backlog, right? Now we still have to decide which those items are, but this is another thing. Okay. Now, upon finishing sprint planning, we have to execute on that, right? And how we do that? By doing work, obviously. Yeah, typing, thinking, shuffling work around. Yes, but we still have to steer our daily progress towards the sprint goal we committed to. And we typically do that in daily scrums. Contrary to the popular beliefs, daily scrums are not daily status updates. They are not status reports of any kind, and we do not use them as such. What are we doing is actually replanning, using them as they're intended as a sprint daily replanning meeting, right? So we are replanning daily for the work to be able to be in a better position to deliver the goal we've committed to as a team. How we do that? Okay, so we are using this another flow metric. In the first situation, you saw that we used a daily throughput for planning and, in our Monte Carlo simulation. Here, we are using work in progress item age, which is important metric on its own right, which give us the cross-section of our items currently being in progress. How long are they being in progress? So from all these items in different states of the process, I can see that this item is the longest in progress, meaning that it entered the system first of all these items, meaning that it was the highest priority item at the time it entered the system, which still means that it is the highest priority item. No changing priorities within the current sprint, right? This is one perspective. another perspective, you can't see colors here well, but trust me. Trust me, this is green, this is yellow, and this is red. So there is, these colors are health zones. Those health zones are dynamically calculated from our system's past behavior. So those are actually cycle times of items being in certain phases of projects. And those help us understand whether or not there is a risk of destabilizing the flow. And we want to have a stable flow, so we can predict better, right? In this particular situation, for this team, this is the obvious outlier, and this team should focus, and we advise it, and we are trying to make people understand to focus as a team on this particular item. These are less important items, regardless of the phase they are in. Okay, so we are doing work day by day. We are progressing toward the sprint goal. And at the end, hopefully, we are reaching our sprint goal, or at least we are ending the sprint. So we want to have feedback on the results we have made. We do that typically in sprint reviews. Sprint reviews sometimes contain demonstration of our work. Sometimes we want to put our work results into hands of our customers to see how they interact with it, to get new ideas, to get feedback, to get the discussion started on how to further populate the backlog, what items to remove for the backlog, and how we can plan for the future release. And now all the party starts. The question that is really, how should I say, taboo in community is when will this be done? So we are ending up with all these sorts of excuses and ambiguities and vagueness to avoid that question, right? But we can harness the potential of this stable system to provide the answer of that question. Oh, to that question. Yeah, I should use proper forms, so yeah. Okay. So yet again, we are using Monte Carlo simulation for this, but from another perspective. If you recall, on this sprint planning meeting, we were forecasting how many items can be complete within a certain date. Now, having all the settings the same, we predict how many items can we finish out up to a certain date. Saying, okay, for this particular team, for this particular occasion, we have release that will contain 30 items, something meaningful, maybe MVP or MMR or whatever. When will this be done? Customer asks. Okay, we can run thousands, tens of thousands, hundreds of thousands of trials, and we end up with probability distribution. What we have there. So now we have different answers to those questions. There is around 85% that we will deliver until 28th November, which is 28th of November or sooner, 85% chance of delivering in that period, which quite accidentally is in like 11 days. And this team, I think, is on track. This still leaves us with 15% of risk of not being able to deliver until then. So we are now switching yet again from guessing or probabilities to risk management, this discussion with our customer stakeholders and between us as a Scrum team. Yet again, now we might opt to, depending on our context, to accept and go as a team with a lower or higher risk, depending on our context. And this is what we actually do with our teams. Okay. When presenting on sprint reviews, something like this, you have to be careful, though, because this somehow draws discussion into performance reviews. And you don't want to have those. on the sprint reviews. On sprint reviews, you want to actually, as I said, get the feedback and to plan for the future, right? We want to actually review our performance as a team, performance of our process, and improve on that. And we do that in, of course, sprint retrospectives, right? Sprint retrospectives, yeah. So, I should be politically correct and say most of us have been in a situation to see an ineffective retrospective. But I will be bold enough to say that I'm really sure that all of us have attended at least one ineffective sprint retrospective, right? Meaning that there is all talk, no action, or there is whining and complaining a lot, no action, or ineffective actions, or recency bias. We focus on things that pain us the most and happened more recently, and such things. Those all things are stemming from the subjectiveness of the event. So we are now, okay, try to review from our subjective standpoint how the sprint went. Now we can put a lot of objectivity into this event, and this comes from flow metrics as well. And this is where flow metrics actually really shine. These are just a few examples of graphs we are using or tools we are using with our teams. And I'll explain those. But there is a whole spectrum of different information you can get from the collected data, so you can make informed decision about how to actually improve your process, removing the subjectivity, right? So this first one is a cycle time scatter plot. It shows us, for the period in question, it shows us all the items completed and how long they took to be completed. So their cycle times. So we can see what are the trends within our system. Is system going to be stable? Is it stabilizing, destabilizing, and gives us hint whether or not we should react? Are there many blocked items? Were there many blocked items? And so forth. This is one perspective for the cycle time. Another is to actually break down the cycle time. So this is cycle time breakdown chart, right? So you can break down the cycle times of individual items, of items as a whole in for the particular sprint, previous sprints, and identify the bottlenecks, blockers, impediments, whatever you want to call them, so you can improve on your system performance. Further, looking in the throughput run charts, you can have, but we are doing that with our teams to understand what kind of output we are making. So what is the structure of our output? Is it business valuable items? Some call them stories, right? Is it bugs or investigations? Or what is the structure of completed items? And this gives us perspective, since many times we are not aware totally what happened in the sprint because we are working, right? And last but not least, the flow efficiency. Easily gameable, but if we are honest enough and want to improve our system, the flow efficiency shows us how much waste we have in our system. Yeah? So what is the percent-wise the effectiveness of our system, meaning that everything else is ineffective. So we can use that to try to find to track the improvement of our process efficiency. Okay, so this completes the tools we are using in our Scrum events with the teams we are working with. Historically, we're also the culprits of doing relative estimations and velocity-based planning. Obviously, those were the go-to methods at the time. There were no sound alternatives, right? And we are not happy with those. We experimented a lot with estimation, with simple counting, but we lose an important perspective of process flow if we do either of those approaches. These approaches, using flow, metrics really remove all those uncertainties and unclarities and help us optimize process further and plan better, right? And deliver on our commitments. So in words of Jeff Sutherland, who is a co-creator of Scrum, process efficiency is the most important metric in Scrum. And I will leave it there with this quote.
Okay. That's...
Yeah.
Thank you. Some questions. There were 3 on much about app, but before that, is there anyone in the audience who wants to ask a question? Any questions? Okay, yeah, go on.
Any thoughts on the Scrum plan?
Yes, yes. Do it. I will go even further. Do Kanban. Forget about Scrum.
But this is Scrum gathering, so...
Unless you are actually... Unless you're actually doing some really important greenfield development of product, and you really want feedback each sprint, and you want to be really focusing on that, do it. Otherwise, if you have a problems, challenges which we mentioned, that's usually a sign that you're actually using a wrong framework. Okay, so here's one question. I know when I saw Duško, I know there will be these kind of questions, to be honest. He's a mathematician, so there you go. His question is, sorry, I'm too old to take glasses out when I read. What's the difference between story points and number of items completed? If we have no measure of size or complexity of those items, or we have high variations which are not visible in these metrics. I'm sure that every one of you were thinking about, does this mean that all our items should be the same size and complexity? I'm pretty sure. Lots of people were thinking about that. But to be honest, the answer is you're not entirely true and correct, because there is this variation. Can you just, oh God, I lost the presentation.
Do we have that on presentation? No?
Yeah, okay, so when we do projections with these percentages of probabilities and risks, we never communicate certain date, just the date. We said it will be on that day or before, yeah, depending on the risk. And variation in this curve which you get depends on your throughput. And throughput is affected by the size and complexity of your item, yeah? So if you have smaller items and you have more regular delivery, obviously you have better chance to deliver that. If you have lots of kind of big size, small size, your throughput will be different. Distribution of your throughput will be different, which will be affected in that, that simulation, yeah? So that's when you take it. And we are not talking about single date. We're talking about discussions. It's up to you. You can say, okay, this is greenfield. I don't take any risk. I'll go with 98% or 100%, which means will be the latest date possible from that. If I know this is the version of software which will deliver, this is another of that kind, I'm prepared to take more risk. So this is simple item, yeah? Simple answer, sorry.
Yeah, and
complexity of your item should be, you shouldn't discuss because of that. You should be discussed because any complex item, any complex item means the team will struggle to deliver that. And the best things to do when you have a complex item, try to think what you can do first. What's the simple thing you can do? To get knowledge and information which will help you in next set of decisions which you do, yeah? I don't know if you're happy with that answer, but that's the answer. Okay?
Yeah, but I just wanted to add to that answer. So it is not that all the items should be the same. All the items should respect and fall into some sort of distribution. Since you're a mathematician, as he said, I guess you know the Weibull distribution. So if it is in the range of Weibull distributions between 16 times of difference of items in size, which is like a really, really huge size difference, you can have a stable system. Of course, you cannot have those many items in either end, but they have to fall in that Weibull distribution. But when you do that, you have the stable system. And there is a lot of room for actually not having the same size items and still have the stable flow metrics, right?
Okay, so let's start with the one who has the most vote. How to use flow metrics when we don't have currently the tools to measure it? Any advice? Jira actually has some of that. You have cycle time scatter plot. It's not most intuitive and the best one, but still, it is one. And you can simulate Monte Carlo simulation using Excel, for sure. And the best things, invest. Because small investment, you will gain a lot from that, because that will give you data to make data-driven decisions. So if you can't persuade your management, you're failing, okay? Try. And if you don't have that kind of possibilities, try to improvise, if you like. Yes?
I just have to add that you can download the Monte Carlo simulator by .North, and there's a template in Excel which has all the formulas inside, so you don't have to make it. It's pretty complicated.
Yes.
So you just put a number inside. There's also like a tutorial how to do it. .North and you can write it in Excel.
Very good. Yes?
In our company, we are using getname.com.
Okay. This is, by the way, from Nave, but we didn't want to advertise. Because they didn't want to pay us anything, you know, so there you go. Okay?
Now, there are a lot of commercially available tools, and it is really trivial to actually do it yourself. Right? But it is always, because those tools are rather inexpensive, it is always a decision between build versus buy. So you can end up with a really effective and maintainable solution for small bucks, but it is up to you. It is really simple to do all this kind of analysis in Excel, for example, using the data from your favorite system of choice.
The second question is very good, actually. We came across that many, many times. And regardless how many times you repeat the same thing, is always the challenge, yeah? So how do you, oops.
Yeah, it's now third.
Okay, so now it's the third, sorry. How do flow metrics influence on team motivation in low-performing team, and how to handle that situation? Yes, this is very good, because as soon as you kind of present something like this, people start closing down, yeah? Because they said, oh, you're measuring something, oh, we'll not want to be that transparent and that kind of stuff. What we're saying is this is for the team. Team should really try to use them, because that should help them remove these functions from their system, from their flow. This show obviously was the problem. And that data, when you have retrospective, for example, my favorite thing is that retrospective is that every team where I've been always says we are a great team, yeah? And I said, okay, from day on, we always know that we're a great team. So let's see if he can even be better than great, yeah? So this should help you discussing real things. And usually when people see that, teams see that, this helps them to have some smart discussions and improve, that's when they accept that. If they see that as an opportunity to do some kind of performance appraisals or something like that, God forbid anything related to your salary or whatever, bonuses, this is nightmare, yeah? So just repeat that every time. Why are we doing that? Like change management. If you don't explain why you're doing that, what you want to achieve and what you're expecting from the people, any kind of change will be difficult to implement, yeah?
And, you know, Scrum is not doing anything. It just exposes the inefficiencies and impediments you have, so you can do something about it. It is the same with the flow metrics. So if it says that you take a long time to deliver something, it is the way it is. You should take some actions to actually speed that process up, whatever that means.
Okay, this is also for Scrum. The challenge I don't see this method is solving is what to do when customer has request for new feature that is big or complex and ask how much it will cost. First of all, this is not Scrum, by the way. The flow metrics nothing to do with Scrum. It came from Kanban, yeah? Good course and certification which you take is Scrum with Kanban. Go on scrum.org and attend that, and you will not waste your money, trust me. Daniel Vacanti, any book from him, great stuff. When it will be done, actionable agile metrics, all this kind of stuff. There's flow metrics for Scrum teams, publication, PDF format. You can find it on the net. It's free. Read it. It's best things which you ever read. Trust me. Okay, so flow metrics have nothing to do with Scrum. And by the way, you should know, but based on the data, how long it will cost. So if you take some item, based on historical data, you will know when you will be delivering that, with what percentage, probabilities and risks. It's up to you and client to decide if you want that or not. And that's what we're trying to say here. If you take one item, use cycle time scatterplot. If you want release or even project with many items, you use Monte Carlo simulation. But just very important stuff. When you look historical data, and the one question here says that, what about if, I think it's Dusan was asking, what about if teams is changing? Yeah, and the environment is changing all the time. What about that? In that case, if your history doesn't reflect your future, you should forget all about this. Because if historically you have a team of, let's say, 5 people, now you have a team of 10 people, historical data doesn't show you anything. Even one member, if you change, that's reflect on your historical data. Yeah? What you need to do instead, you need to collect data, and after that, make that decisions. How long does it take to have some kind of reliable data? I don't know if you mentioned that or not. It's about a month, maybe a sprint or 2, if you like. 2 sprints should be enough for you to have some data to help you with making decisions. This first question, I'm not sure what you mean by cost. So what do you mean by cost? No, there is no estimation. I'll tell you. If you put that now, you will get that, let's say, by what's today?
It's huge, and you don't know whether it will be 1 or 15 backlog items on your status.
If it's one item,
Then it's
it's easier.
easier.
If it's easier. If it's many items, it's about risk. If you're not sure, if it's complex item, if it's certainly you take less risk for sure. Because your 98, 99% certainly took in account any kind of complexity similar to that in the past. Yeah? If you jump to 50%, that means you're ignoring that outliers which you had in the system. If it's something completely new, that means your historical data that have no value whatsoever. Yeah? So what you do if you don't have any of this? Of course, story points.
This will tell me like it will be over between now in a month or in 12 months with certain probability.
Yeah, but that's certain probability. I mean,
I know that.
this is guessing game. This is certainly will give you ranges, not be that huge. But don't forget, first things first, you need to stabilize the flow. Otherwise, there is a problem. And what I would suggest is this complex stuff, you need to really think about how to split that in small chunks, or smaller, should I say.
And this is really the key, since if it is like a big or complex, how do you know it is big?
Well, because it's weird request, so I don't know what it is, and
Yeah.
that's why I need to work on it, to refine, to have the small items, and then this is great.
Yeah, of course. And what is the alternative? Just to speed out the number, whatever method you use, right?
We call it guessing.
Yeah. So there is, you can use the structural approach to see, okay, so this is uncertain, this is big, how big, I don't know, what is in there, I don't know, let's open it. And see what is in there. So now we have in a ballpark, right?
So if you remember, the daily throughput there was presented, and you have some kind of deliveries, and certainly you have gaps, nothing deliver for many days, yeah? And all of a sudden they have some, that's usually indication they came across something like that, okay? Something big, something complex, yeah? When we do simulation, Monte Carlo takes this into account. That's why it gives you different type of risk and probabilities, yeah? Here, focus should be on your discussing with client rather than giving them just simple date. You're discussing how much risk you're willing to take. And the same thing is with the sprint as well.
We have a couple more minutes. Do you have any questions more?
Yeah, there was one here. Where is...
Tools, disperse, how the flow metrics.
yeah,
influence
so
the-
I answered all this.
Yeah.
So any more questions? Yes? Say it again.
Which metric should we use, or which metric suggests that the team is not the issue, that actually the business has the issue, or the PO is having the issue, so the fluctuation in the sprint goals, or even the vision of or the direction of the product is the problem? Which one then to use?
Okay.
Is there any metric?
So flow metrics are not magical, let's be honest. Okay, they will not answer that question. But they will provoke discussion, and you should have root cause analysis about this, okay? But you have data who shows you that, support that. Otherwise, people say, how do you know? This is outlier. Usually what we do, there is some outlier, and usually ask him, okay, what's that different compared to the rest of your stuff? Because if you use this scatter plot, it shows you all your items, when they completed, which day, how long you spend on them. And there is one who's jumping like this. And my question is, okay, why is that different compared to everything else you did? And that's when the people start talking about this kind of problems. Yeah? And you start asking why, what's root cause analysis and that kind of stuff. Yeah? But flow metrics will not give you any of this question.
Yes, but if you combine those, you get,
Yes.
they will suggest.
Different flow metrics is for different things. We try to present you what you can use for each of these items. Yeah? So I would go with what Bojan was talking about, retrospective. Yeah?
Cycle time breakdown can show you where the inefficiencies, so you can look into those. So maybe the structure of throughput. So why do we have so many investigations or bugs? What's happening? We get unready items into our system and so forth. So you can, there is no any measure saying, yeah, this is the problem with the PO, but you have to be smart about things. You have the hard measure, and now you can analyze. Yeah?
So we usually, when we do this, we introduce Kanban principles. So one of Kanban principles, you have pull system. To be able to have pull system, you need to have a ready column or buffer column between two of your columns, which represent some status, for example, development and testing. Yeah? Without ready column between, or waiting column between, you don't know what's your flow efficiency. Yeah?
Now, another question from my side. That's regarding the work in progress. You need to limit the number of
Yes.
work in progress times.
Yes.
How do you decide? When is the right time to decide for the new team which work in progress
Okay.
limitation to use?
This is a great question. By the way, if you implement Kanban without WIP limit pull system, you're not having Kanban. Yeah? So what usually teams do, first they said, okay, let's limit each of our team member working on one, maybe two items, okay? You can even split that, saying developer can do, yes. And after that, they move from that, saying, okay, let's do per column, which represents certain development, for example, development, code review, testing. And after that, the end of goal is to have work in progress for all your in progress stuff, yeah? And usually it should be one team member minus one, yeah? But that's the painful activities, for sure.
Time's
Okay.
up.
Yeah, okay.
Time's up, and you qualified with your questions for discussion with me next week. So, okay, so thank you very much.
Okay, thank you.